Good afternoon, everyone, and welcome to this occasion celebrating Yakir Aharonov's 90th birthday. My name is Ady Stern. I'm from the Weizmann Institute of Science, and even though I was not officially Yakir's student, I consider myself as if I have been one. I'll serve here the role of calling people and introducing them. And our first speaker for today would be President Professor David Harel, the President of the Israeli Academy of Sciences, that's hosting us today.
So first of all, a confession. I'm sorry? No shomim? I think maybe I shouldn't be standing up here because when I was in high school, this is Netiv Meir here in Jerusalem, there was the possibility of writing a kind of small thesis in the 11th grade in order not to do the formal matriculation exam in some other subject. So of course many people, they did a thesis in literature or in a Tanakh, Bible, in order not to do math or physics. Some the other way around. I did not like physics. I liked mathematics, pure mathematics. I was pretty good at it. And I did a thesis in pure math, spherical geometry and trigonometry, and I did not have to do the Bagrut in physics. So maybe someone else should open this conference. Anyway, good evening, everyone. Good afternoon. Dear Professor Yakir Aharonov, my dear friend, Professor Dorit Aharonov, FOE, as well as Nili, Ranit, and the rest of the Aharonov family. Professor Sir Michael Berry and Professor Sandu Popescu from the University of Bristol, who came especially to honor Yakir. Academy members, Professor Moti Segev and Professor Ady Stern, who co-chaired this event. Distinguished guests here at the auditorium and online. So it is a real privilege for me to open this conference, which celebrates the 90th birthday of one of the most brilliant scientists Israel has known, a true pioneer of quantum physics. I recall arriving at the Weizmann Institute in 1980 as a very young scientist. There were a handful of senior people in the landscape of Israeli science whose names were continuously mentioned by people of my generation in awe, almost as if they were gods. The undertow was something like, these are the people one should aspire to be like. Yakir was at the very forefront of this select group, and over the years, the profound nature of this positioning became increasingly obvious. Let there be no doubt about it. Today, we are honoring a truly great scientist, one of the very, very best. As to Yakir's area of research itself, one can still argue about Albert Einstein's famous phrase that God does not play dice with the universe, although in a later 1945 letter he softened this a little bit by saying that what he really meant was that God does tirelessly play dice, but under laws which he himself has prescribed. In other words, what Einstein, I think, was really saying is that quantum particles must adhere to rules that don't change randomly, and significantly that the quantum world required better explanations for the behavior of particles. Einstein aside, when one looks closely at this exciting field, bubbling with the activity of some of the brightest scientific minds of our times, one finds many outstanding results discovered in the process of actually trying to tackle difficult and often mysteriously sounding problems, which brings to mind another famous quote, this time by John Wheeler: if you're not completely confused by quantum mechanics, you do not understand it. It is not for me, not only because I did not like physics, to list Yakir Aharonov's research achievements, mainly because most of them I would be hard-pressed to even vaguely understand. Still, the 1959 Aharonov-Bohm effect stands out as something even people far from physics have all heard about, a simplistic version of which some of us even half understand. I'm sure we will hear more about this later. As a computer scientist, I have my own egocentric interest in things quantum, especially those parts related to quantum computing, such as the viability of building useful and powerful quantum computers, and the area of quantum cryptography, which has also been buzzing with research for many years. I presume we shall hear a lot more about these issues later on from Dorit, maybe from Ady. However, since one of my own pet interests is in the inherent limits of computation, I'd like to steal a couple of minutes to describe what, to my mind, is the most fundamental open problem in quantum computing, at least from the foundational theoretical point of view. Is there an algorithmic problem that has a polynomial time quantum solution, but which can be proved to admit no classical polynomial time algorithm? To use the terminology we computer scientists use, where reasonable or tractable are the terms we use when we have polynomial time solutions, the question is really this: is there a computational problem which is tractable in the quantum world but is provably intractable in the classical world? And this problem is still wide open. I see a couple of frowns in the audience, which are most probably a result of your acquaintance with the 1994 work of Peter Shor, who exhibited an ingenious polynomial time quantum algorithm for factoring integers. A wonderful piece of work indeed, but it would be orders of magnitude more significant if we were able to prove that factoring is not in polynomial time in the classical sense, and this we don't know. In the year 2000, I published a little book on the inherent provable limits of computation. The title was Computers Limited, What They Really Can't Do, from Oxford University Press. And I chose to end the part that discusses various approaches intended to alleviate some of these limitations by writing, quote, "In summary, Shor's factoring algorithm constitutes a major advance by any measure. However, at the moment, it must be relegated to the status of shelfware, and it is probably destined to remain that way for quite some time." And the final words of that chapter were, "Intractability has not been beaten yet." Incidentally, it occurred to me that the quantum phenomenon of particles being able to be simultaneously in more than one place at a given time correlates nicely with the Jewish belief that God, and we mentioned him or her earlier with the dice, is really everywhere all at once. And this reminds me of the following anecdote. And this reminds me of the following cute anecdote. Rabbi Levi Yitzchak from Berdyshev once met a young child and said to him, "I will give you a coin if you can tell me where God is present right now." To this, the child answered, "I'll give you 2 coins if you can tell me where God is not present right now." So I'd like to wish Yakir many more years of good health and productive work, and may you continue to be a unique inspiration to us all. Sincere thanks to the wonderful staff of the Academy for organizing this event, Dr. Yael Ben-Chaim, Aviva Levi, Kochi Maimran, Michael Zaguri, Yaakov Rotman, and our excellent CEO, Galia Finzi. Thank you, and have a pleasant and interesting evening.